Hello, in this video, we will show how to calculate probabilities for discrete distributions using R. So for the discrete distributions or discrete random variables, what we can do is to calculate the probabilities for a single value. For example, we are interested in the probability of x equals x. So this is a specific value for this distribution, or we call this is a density function. And we can also calculate the continuous cumulative probabilities for a discrete random variable. So this is expressed as probability of x less than or equal to x. So this is also a specific value. So for example, for the binomial distribution, so we can use d binom for this simple or single values or simple probability, and for the p binom for the cumulative probability. And in R, the probabilities for discrete random variables, it follows also the dp with the abbreviation of the random variable, for example, d binomial, and dGOM for the geometric distribution, and dPys for the Poisson distribution, and p also. So next we go to RStudio to show these operations. So first, for example, we want to calculate probabilities for a binomial random variable x with 10 trials, and with each trial has a success rate of 0.5. So for the binomial distribution, we want to calculate the probability of observing x equals 7. So here 7 is the success times, and for each trial has a success rate 0.5. So we have 10 such trial. And this trial also called binary trial. And this is a binary result, true or false, or success or not success. So we just use the binom 7. This means the number we want to calculate upon with probability. Size is 7 and probability is 0.5. So it is about 0.11. So about 12% of the chance that this trial can get 7 success, right? And we can also use p binom 7 with the size and 10 0.5 to calculate the success time less than or equal to 7 in such 10 trials. So there are about 94% of the probability that these 10 trials will get less than or equal to 7 successes, right? Then we will talk about the geometric distribution. The geometric distribution is quite similar as actually is the same trial as binomial distributions trial. So we also have 10 trials, and we have probability of 0.5, so each trial's success rate. But geometric random variable is to model how many times trial passed until you get first success, right? So here, we do not need to define how many trials total, because we do not know the number you get the first trial. So for example, we can create a vector with a sequence from 1 to 10, and with the gap 1. So which means we want to calculate the probability of getting how probability of getting first success, then how many trials passed. So here we want to know the probability of just one trial you can get first success, or you take 2 trials to get a first success until you get 10 trials get your first success. Then we can calculate such probabilities using DGEOM. Here we just input this vector. We set the probability for success in each trial. Then we can plot these probabilities. So you can see in a trial with a success rate of 0.5, so almost you get success from the first trial's probability is about 0.25. Then you get a first success until you have 2 trials is about 0.13, right? And so on. For example, you can get your first success until 4th trial is about 0.04, very low probability. Because here, the success rate is quite high, 0.5. And similarly, we can also calculate the cumulative probability for such geometric random variable. So here we also, with the input x, d, GUM, the vector from 1 to 10, with the probability 0.5, and we use PGUM function. Then we plot the probability. So now this is the cumulative probability. Actually, this is the cumulative from the previous probability from 1 to 10, right? So you can also find, for example, about 0.86, about 85% of the chance that you can get your first success within 2 trials, right? And almost 95% of the chance you can get your first trial and within 3 trials, right? So here 3 means the random number can be 0, 1, 2, 3. So this is the cumulative probability of random number less than or equal to 3. So which means 95% of the chance that you can get your first success within 3 trials. So this is the cumulative probabilities for geometric random variable. Then we talk about Poisson distribution. So the Poisson distribution is to model a random variable which is also discrete for the very small success number within a fixed time interval. So for example, in a telephone call center, average one day has 10 times telephone coming in. Now we want to calculate a next random variable also following such kind of Poisson distribution, and we want to know what's the probability of the next day coming exactly 10 telephone calls in this call center. So we can use DPOIS 1010. So the first 10 is this random number. The second 10 we call lambda or call mu is the average number for this random variable. So average one day is 10, but next day we want to calculate how many, what's the probability of exactly coming 10 calls. So DPOIS 1010. About 0.12 chance that exactly 10 calls coming in, because the other parts of the probability will attribute to, for example, 9 times, 8 times, and so on. And similarly, you can also calculate, for example, in a call center with average one day 15 calls coming in, then next day, how much is the probability such coming in exactly 2 calls? So D POIS is very close to 0. So average one day is 15 calls coming in, then one day only 2 calls come in. This will comes a very low chance, right? Of course, we can also calculate the sequence from 1 to 20. For each these random variable, we calculate the exact probability and plot. So for Poisson random variable with the average 10, so you can see the probability is close to 10 is very high, and far from the 10 will be very low. Then we can also use cumulative probability. For example, we can calculate the probability of telephone coming in less than or equal to 10 in such Poisson distribution. For example, average daily 10 telephones coming in. So what's the probabilities of coming in 0, 1, 2, 3, 4 until 10, right? So using POIS 1010. About 58% of the chance that next day will come in telephone calls daily will less than or equal to 10 in such Poisson distribution. And what's the probability of coming in 0, 1, or 2 telephone calls next day from a Poisson distribution with average daily coming in telephones 15. So here you can see also very close to 0. So the average daily coming 15 calls, so the next day coming the probability of 0, 1, 2 in total is also very close to 0. Then we can calculate and plot these cumulative probabilities from 1 to 20 in a Poisson distribution with average 10. So this is from 1 to 20, and actually for the 10, about 0.5, right? So average telephone coming in, for example, is 10 daily. So next day, the total probabilities of coming 0, 1, 2, 3, 4 until 10, their total is about 0.5. So 50 of the chance that next day will come in telephone calls will be less than 10, less than or equal to 10. And another 50% of the chance that next day coming in telephone calls will be larger than 10, right? So this is the Poisson distribution, and we have shown here the probability calculations for discrete random variables, binomial, geometric, and Poisson random variables. Thanks for watching.